today we're going to start by talking about evaluating functions and also function composition. So in order to start with evaluating functions, when we're given, for example, the following examples, and number 1 asks, what is f of 2? What that means is, what is the value of the function when we replace x with 2? So we go to the function f here that says x minus 7, and we replace what's after equals, so that f of x just means function x. So we replace this x with a 2. So it would be 2 minus 7, which would give us negative 5. So that means f of 2 is negative 5. For number 2, it means go to function g. So function g is right here, and replace x with 3. So we would have negative 2 minus 3 squared. Well, 3 squared is like 3 times 3, so that's 9. So that's negative 2 minus 9, which would give us negative 11. In number 3, it says, what is f of negative 2 plus g of negative 3? Well, what this means is we need to go to function f first and replace x with negative 2. So we'd have negative 2 minus 7. And then we need, so negative 2 minus 7 is negative 9. And then we need to go to function g and replace x with negative 3. So we would have negative 2 minus negative 3 squared. Negative 3, the quantity squared, because that represents x. So negative 2 minus negative 3 times negative 3 is 9. So negative 2 minus 9 would be negative 11. So our answer would be found by taking that negative 9 and adding it to the negative 11, which would give us negative 20 as our final answer. In continuing to talking about evaluating functions, we can also use this concept to evaluate functions from a graph. In doing so, you're just considering that value in parentheses is the x-coordinate, and you're looking for what is the output, meaning what is the y. So for example here, for number 1, it says what is g of 2? So that means go to the graph, go to graph g, which says it's graph g. When x is 2, what is y? Well, x is 2 right here, right there. Y, the y value there is negative 1. In 2, it means go to graph g. When x is negative 6, come over here to where x is negative 6 here. What's the y value with it? That y value is 1. And last, number 3, go to graph g. When x is negative 1, so x is negative 1 right here, what is the y value? The y value is 0. So in building off of that, we're going to talk about evaluating functions using composition. So ignoring the notes that are up, well, we don't want to ignore them, but I'm going to talk about them as we go. So if we're given function f, we're given function g as ordered pairs here, we want to find f open circle g of 2. That open circle means composition. It means it's the same as I underline here, g of f of x equals g of f of x. That means composition. So you work from the inside out when you see this. So when you see this, work from inside out. Meaning, I'm going to rewrite 7 using that notation. F of g of x means this. So I'm going to write it this way. So in using that, if I work from the inside out, that means go to the inside, find g of 2 first. Well, go to function g. When x is 2, what is y? It's 3. So now I want to go to function f here, and I want to say when x is 3, what is y? Y is 4. That's my final answer. You work from the inside out. So let's go through another one, what that would look like. So for 8, g of f of 3. Work from the inside out, so you're going to go to function f first. When x is 3, so when x is 3, what is y? It's 4. Now I go to the outside letter g, so now I go to g. When x is 4, what is y? When x is 4 in g, y is 3. Remember, by notation number 9, this is the same as writing g f of 1. I don't like that original notation. I don't think it makes as much sense as writing it the way that I always end up writing it. The reason why I give it to you both ways is because you need to be able to recognize how to rewrite it between the two different notations, because you could be given any of those in a realistic scenario. So work from the inside out. So go to function f. Function f, when x is 1, y is 2. Now take that to the outside function g. So now in function g, when x is 2, what is y? It's 3. 10 is the same concept. I'm going to rewrite it. F of g is 6. I'm not changing the order of the f and g when I'm rewriting it. Keep that in mind. So I'm going to work from the inside out. So I'm going to go to function g. When x is 6, y is 1. Now I'm going to go to the outside function f. So if I go to function f, when x is 1, what is y? It's 2. So my final answer there would be 2. Now let's move on to putting this with actual expressions, with x's, with variables, not with just ordered pairs. So in number 11, we want to find h of g of 2. So still the same concept. So this is the same as rewriting it h of g of 2. Work from the inside out. Go to function g, replace every x with 2. So I would have 2 squared minus 3 times 2 plus 6. Type that quantity in a calculator. Think about it. 2 squared is 4. 3 times 2 is 6 plus 6. Go in order from left to right. 4 minus 6 is negative 2. Plus 6 is 4. Now I take that to the outside function h. So in h, I'm going to replace every x with a 4. So that would be 4 times 4 minus 1, which would end up giving me 16 minus 1, which would be 15 as my final answer. In moving on to number 12. Work from the inside out, so I'm going to go to function f, replace every x with negative 10. So I'm going to have negative 10 plus 7, because right here is f of x. Negative 10 plus 7 is negative 3. Now I'm going to take that to the outside function h. So in function h, I'm going to replace every x with a negative 3. So 4 times negative 3 is negative 12 minus 1, negative 13 as my final answer there. Moving on to number 13, I'll work from the inside out. This time I'm not replacing every x with a number, I'm replacing x with x. So what that means, g of x, I'm going to replace x with x, so that's just going to stay g of x. X squared minus 3x plus 6. Now I'm going to take that entire quantity to h and put that entire quantity in place of x and h. So h, the expression says 4 times x minus 1. So 4 times this quantity, x squared minus 3x plus 6, and then minus 1. So I'm going to go ahead and I'm going to distribute the 4 to get 4x squared minus 12x plus 24. Drop down the minus 1. Combine like terms. Whoops, I forgot the squared. 4x squared minus 12x. 24 minus 1 would become 23. So let's look at problem number 14. Remember, I always like to rewrite it. This is the same as saying g of h of x. So work from the inside out. Inside h of x is equal to 4x minus 1. I'm going to take that to the outside function g and put that in place of every x. So g says take the quantity x squared. So in this case, that would be the quantity 4x minus 1. And then it says subtract 3 times the quantity of x plus 6. So I have some work to do here. That quantity 4x minus 1 squared is the same as writing 4x minus 1 times 4x minus 1, which you can find the answer to the result by doing the box. So if I do 4x times 4x, I'll get 16x to the second. Negative 1 times 4x would be negative 4x. 4x times negative 1 would be negative 4x, and negative 1 times negative 1 would be positive 1. So this quantity, and then I could combine like terms. Negative 4x minus 4x would be negative 8x. So I'm going to take this quantity and put it in place of that quantity squared. That's what I just did. So I have 16x squared minus 8x plus 1. Then I'm going to go ahead and distribute this 3. Whoops. This 3 just goes to 4x and to negative 1. So negative 3 times 4x is negative 12x. Negative 3 times negative 1 is positive 3. And then I'm going to drop down that plus 6. From here, I should just combine any like terms I can. So I have 16x squared off on its own. Negative 8x plus negative 12x would be negative 20x. And then I have positive 1 plus 3 plus 6 would be positive 10. And that would be my final answer there. All right, so we got one more problem I want to review together for the last one here. So we have 3 different functions. It's still the same concept. So like I could give you 10 and you should be able to do it if you understand the concept. The concept is you work from the inside out. So go to g of x. So what is g of x? G of x is x squared minus 3x plus 6 by what it says right here. I'm going to take that to the next letter outside, which is f. So I'm going to take that to function f. So put this in place of x in function f. So you'll have x squared minus 3x plus 6, and then it says plus 7. So let's go ahead and combine like terms to simplify that. Combine 6 and 7 to get 13. Then I'm going to take this to the final letter, which is h. So now I'm going to take this to h of x, put this in place of x, where I'll have 4 in place of x, x squared minus 3x plus 13, and then it says minus 1. So I can go ahead and distribute that 4 to everything after it. (13 times 4), I would get 52. And then I can drop down that minus 1. And then I could combine like terms. So I would have 4x squared minus 12x plus 51.